Hi everyone, are you able to hear me and see my screen clearly?
Yep.
All right, great, great. Okay, so, all right. So I think there are a couple of more people who are joining. Just give, let me start in 1 minute. Okay, so I'm going to pause the audio for 1 more minute and be back in a minute. All right, so I'm back and let's start the session. Do you have any questions before we start? There's a question from Sanjaya that I can't record the session. Do you want to record the session? I'm anyway recording it on the cloud. Okay. If you want, I can make you record the. If you want, you can record it now. I have just allowed you. Okay. Great. Wonderful. So, do you have any questions for me before we start? Okay. So, I think I have questions for you. So were you able to go into a CloudX Lab and then my courses and this particular course, and were you able to start finishing these exercises? Great, great. All right. Any questions before we start? All right, so let's start. So we talked about various guarantees that Zookeeper provides. Okay, sure, Anup. We can take a live example. All right. All right. So who uses Zookeeper? Zookeeper is generally used by your application, and mostly the application talks to Zookeeper via API. We will take a quick look at the API and then, okay. So these were the various guarantees provided by Zookeeper, starting with sequential consistency, atomicity, single system image, durability, and timeliness. Okay. All right. Now further, these are the methods provided by Zookeeper to you: create, delete, check if it exists or not, and get the access control list, change the access control list, and get the children, get the data, and then synchronize our client's view of Gnode with Zookeeper. Okay, because client's view could go stale, and therefore, as we discussed yesterday, that in order to remain, in case you are connected to an older node, there are chances that there is a newer data, and you can explicitly synchronize your view to the Zookeeper. Okay, now whatever changes we do, along with that, along with get, set, ls, and create, all of these changes could be combined together into batches, such that either all of those changes will be successful or all of these fail. Thus, we can use multiple updates as the you can use the multi-update facility in the API for the transactions, right? What's a transaction in databases? When you have multiple queries and you want either all of those to succeed or fail, that's a transaction. And in the transaction, you have no middle state. You either have all of these successful or nothing successful. In the same way, Zookeeper also provides you the multi-update functionality with which you can kind of emulate the transactions. Okay, so either all of the commands, all of the chain of commands will be successful, or all of those will fail in a multi-update, and nobody will see the inconsistent state. Okay, let's take a quick look at the APIs. So far, we have interacted with Zookeeper by the way of command line interface. And that was a quicker way of looking at it. Now, there are two APIs. These are the two core APIs. One is Java and C. So if you are working with Java or C, you can use the APIs. And the kind of functions provided by Java and C, the other programmers have contributed the API in Perl, Python, and REST interface. Okay, with these API, you can actually call Zookeeper from anywhere. And for each function, there are two kinds of functions available. For each functionality, there are two kinds of functions available. One is synchronous, other is asynchronous. Okay, what does it mean by asynchronous? Anybody? So this is how asynchronous functions look like. This is how synchronous function looks like. Here, this function is written in Java. This function takes, this is the name of the function. This is the name of the function. If you use it, here we are defining this function. We can use this, we can call this function using this name. And while calling, we can pass these two arguments to the function, and it would return the stat object. Okay, it's public and it throws these kind of exceptions in case of failures and so on. So this is kind of the footprint which the API has for a function called exist. Similar function exists for get data and set data, as well as other functionalities. All right, now what is important about this function? This function, when you call this function on the Zookeeper object, this function will make you wait. This function will make you wait, and if this function is taking a lot of time, your program will stay hanged till the point this function returns. Okay, so this is called synchronous way of calling. You call a function, it makes you wait till it gets the result, and once it gets the result, it returns those values to you, and that's it. This is called synchronous way of calling things. Okay, thank you, Fakhruddin. So the asynchronous function, we also call that async. They basically, you submit the job for execution, and then once it's done, it sends you an event. It calls you back. Okay. This was, so you are passing one path. Second is the watcher. What does watcher do? Watcher provides you a way of events on these nodes. Okay. So the second function is like this. It's a sync function in which there are, other than these two arguments, right? Path and watcher, there are two more arguments and it does not return anything. Okay, so then what happens? What happens here? How is it different from sync? So when you call an asynchronous function, it returns immediately. It starts the work, but it gives you the control back saying that we will let you know once work is done, you continue. Okay, that's what asynchronous is. Asynchronous starts working in background while letting your program proceed. Okay, so if you call async API, the exist function, it will let you move ahead. It will return immediately and will start the work in background. The question is, how you get to know that it has finished the work? How would you get to know that it has finished the work? It will call this stat callback. You will have to create an instance of stat callback and pass it here so that when exist finishes work, it will it will call this function to inform you that it will call a function of stat callback to inform you that it is done. Okay, then if you want extra object to be passed here, if you have extra object to be passed here, you can pass those object. Okay, all right, so these are the synchronous example, asynchronous and synchronous examples. So this is a very high level overview of Zookeeper. We have not planned to go into much details, but if you want, I can maybe prepare a full small project on Zookeeper so that you can connect. All right. So far we have not planned for going too much detail into the APIs part. Okay. So maybe we can prepare this next time. Also, most of these APIs are used by your program, as in if let's say you're building an application like MapReduce, or you are basically building a platform, a framework, or a service, then you will use the API in order for synchronization. Okay, so all right, I do not have an example ready, but we can prepare maybe over the week and we can discuss it in the next session. All right, Sanjaya, and I think Anup also. So we can go over into more details, or maybe we can schedule a separate session just for this part. All right, or I'll publish it over the GitHub, and there you can take a look. All right, great. Now here I'm just trying to give you an overview. How does a coordination system work, and how do things happen? So let us say that, so how many of you have used database triggers? Has anybody used database triggers so far? Good, good. So almost everybody here. All right. So let me explain what is a database trigger. So you have tables in a database, right? You have tables in database, and tables has rows and tables have columns. So if something happens in a table, you can listen to it. For example, a row is deleted, a row is inserted. So you can listen on a table that in a way that you can execute your own logic, own program when a row is deleted, row is inserted, row is updated, and so on. These are called triggers. Okay, listening or watching the events over database table. That's an trigger. Okay, the similar to triggers, Zookeeper provides something called watches, so that so that you can watch a particular Z node if it is changing. Okay, if it is changing, you can watch it. For example, there is a list of servers and some servers are disappearing. You can immediately be informed that some servers have disappeared. Okay, or a particular Z node has been added. Okay, so the clients can get notifications when a Z node changes in any way. That's what is a watch. So watch is like a handle to your function that you give to Zookeeper, that here's my function. Please call it once something happens to Z node. Okay, but please note that watches are triggered only once. They don't keep on re-triggering. If you want to, if you want to get multiple notifications, or whenever any Z node is being added or modified, what you do is you you basically re-register inside the trigger itself. Okay, the trigger will create another watch, and that's how. Okay, so watches are triggered only once, and this model is very common with most of the systems. So say, for example, the read operations such as exist, get children, and get data may have the watches, meaning while you are calling exist and get data, you can pass your own function saying that whenever anything changes on this particular Z node, please call these functions. Okay, so watches are basically triggered by the modifications on a Z node, right? Could be delete, create, or set data. ACL operation, this is something new. So there's something called access control list on Z node, okay? Because a zookeeper is accessed across the organization. If you have an organization, you would having a data center in which Hadoop or similar services are running, the chances are you would have Zookeeper. And this Zookeeper could be used by many applications. And when many applications use your Zookeeper, you would definitely require kind of a permissioning. There should be a way to control access. Who is allowed to access which node? That's defined using ACL, access control list. Access control list can be usual like login password. It could be based on single sign-on things like Kerberos, or it could be based on IP address. Okay, so you can also define the access control list, and the access control operations do not participate in watches, meaning when you change access control list, it does not trigger any kind of, it does not it does not cause any triggers of watches. Okay, so and this is a quick list of things. So the watch of, so when you are calling a function called exist on a particular G node, you are saying exist. Okay, so while calling it, you can also provide a watch along with this so that you can watch the same node on which you are calling the exist function. What does exist do? Exist checks whether a particular G node exists or not. Okay, so if it does not exist, then whenever it gets created, the watch will be called. Okay, if it exists, then whenever the Z node is created or deleted, the watch will be called. Okay, and or modified. So whenever, if the Z node already exists, so exists will return true, Along with that, whatever watches you have provided, they will be triggered later on when this G node is deleted or modified. Okay, so that's the triggers of watches. The triggers of get data is called when Z node is deleted or has its children. The or sorry, the when you call a function like get data, it returns you the data. It also hooks the watches what you have provided as second argument, and if the if the Z node is deleted or the data is changed, the watches will be called. Similarly, there's a function called getChildren, the ls command. All right. Then for getChildren, whenever something happens, so whenever a children is deleted, created, or anything happens to the Z node, you get a trigger. Okay. A question from Rakesh. Question is, why is that different than exist? Why is get data different than exist? Okay, so exist basically is the way they have designed it. First, second is exist can be called on any Z node, whether it's existing or non-existing. Okay, therefore, when exist is being called on a Z node that does not exist, and it returns false, but the watch that you provide with it will be called when in future that Z node that you just checked gets created. Okay, so that's the way it is. Get data can be called on the Z node that already has. A question from SP. So most of the trigger events occur underneath the hood. Yes. Okay, when you call it from the API. Okay, so that's about watch triggers. Access control list, as I have quickly described. Access control list determines who can perform which operations on a particular node. Access control list is a combination of authentication scheme, meaning how to authenticate a person, as well as an identity for that scheme and a set of permission. Okay. The authentication scheme can be either digest, meaning challenge based like login and password, or it could be based on SASL, for example, using Kerberos or any single sign-on policy, or authentication scheme may be based on IP address. Okay. Now, there are many use cases of Zookeeper. So whenever you are building a distributed service or distributed application, most likely you will use existing frameworks. But if you are building your own framework, in those cases, you will need Zookeeper. You will need to talk to Zookeeper. Here are some of the use cases. Okay. A question from Sanjaya. What is SASL? Let me recollect. SSL is Socket Authentication Service Layer. That's, I think, Security Authentication Service Layer, something like that. I'm just missing one S. Okay, so yeah, either is Socket Authentication Service Layer or it's Security Authentication Service Layer. All right. Okay, a question from Anup. What is Kerberos? Good question. All right, let me describe. It's a very important question, and yes, it's good that you asked that. Okay, so in an organization, let's say you are working for an organization whereby there are many machines, many laptops, many servers. So instead of logging in every time, you log in only once. You log in only once. Okay. And the way it happens is there is a central service which authenticate a machine, keeps your token, and whenever some service wants to take your identity, they take it from the central service. Okay. One of such systems that provide this single sign-on policy is Kerberos, and the other is LDAP. So, so you can use either of the two. Okay, so most of the organizations which are Linux-based organizations, they use Kerberos specifically in the data center so that they don't have to maintain separate login password for every service, and there could be, and they don't have to provide login every time. Okay. Second is the LDAP or NTLM. There is a NTLM authentication service provided by Windows, and that's also used frequently in the Windows-based environment. Okay, NTLM. Okay, uh, thank you, Gaurav. Yes, so it's simple authentication and security layer. All right, I had kind of forgotten the definition. Okay, so I hope I have cleared Kerberos and yeah, I've not confused you further. Great, great. Okay, so you can build a reliable configuration service using Zookeeper. Okay, what does it mean by a reliable configuration service? You can keep some of the data that's changing relatively faster in Zookeeper and let the system pick the data from there. Okay, keep in mind that you keep only that piece of data that is changing really fast in Zookeeper, not the one, not the one that, not the one that is huge and relatively static. Okay, why? Because we will understand it sooner that if the data is really huge in gigabytes, it would not work out. Okay, so the configuration, like if it is in a few megabytes, it's completely okay with Zookeeper. Let's say you want to build a distributed log service, then you can use Zookeeper instead of building your own. Okay, so that only single process may hold the lock, right? So how would you implement, say, a distributed log service? You will keep on creating the Z node, okay? And the way we had described yesterday, that was essentially a distributed log service, okay? And when not to use Zookeeper, that's more important because we start feeling that it's the solution to everything. Let's understand when not to use. One, do not use Zookeeper when you have really humongous data, because the number of copies is equal to the total number of nodes of Zookeeper. Total number of machine on which Zookeeper is installed, those many copies of the data will be there. Second, all of the data that is kept in the disk will also be kept in the RAM too. That's far bigger a reason not to use Zookeeper in case of big data. The network load of transfer is really huge, because if the bigger is the data, because it has to transfer the entire data to all of the nodes, the leader has to send all of the data to all of the nodes, and therefore there is a transfer cost involved in Zookeeper. So if you have bigger data, if you are adding more and more records of huge size, the network will be impacted. Second is, second use case is when you really want uh, extreme strong consistency, meaning you cannot tolerate the delay of even a millisecond in your data. Okay, in even a millisecond. Okay, in those cases, you should avoid using the Zookeeper. Okay, so that's pretty much with respect to Zookeeper. Any questions for me? Let me see if I can come up with a proper exam, a proper maybe Java project or something. I'll put it on my GitHub and share it with you. Okay. Let me just note it down. Great. A question from Kiran. What is the optimum size of the data to use with Zookeeper? So to speak the threshold. Okay. Yes. So good point. So in this case, I would say that if your data is in megabytes, okay, you can keep using Zookeeper. But the moment you start crossing hundreds of megabyte data, then you avoid it. Okay. Or keep the secondary storage. For the relatively static data, you put it in, say, HDFS, which we'll discuss soon. And for less static data, you keep it in Zookeeper. Okay. A question from Sanjay. Any assignment on Zookeeper? Yes, there are quite a few assignments. So I would request that you take a look at here. You see it here? So it will, there are 47 pages here, and most of it is actually assignment only. Okay. So here, let's say it will ask you to create a sequential node. Okay, there is one assignment that it will ask you to do that. Okay, so hands-on here. Like for example, here, not this one, I'm sorry. As you will go ahead, you will figure this out. Okay, so please finish this. Yeah, here. For example, it is asking me to create a particular G node. Let me see what it says. It says that the G node does not exist in the CloudX lab. So I'll have to create this one. So if I do this, if I, okay, let me just show you this. This is something I would like to show you. There's something unique about us, and we built it so that everybody can do the proper hands-on, and they can't really fake with it. Okay, so I'll show you. And let me log in into this lab first of all. Are you able to see my screen clearly? Ouch. Let me log in again. Okay. That's my login. Do you mind if I switch my network? I, by mistake, switched to a slower network, so I would like to switch it back. Okay, so there could be a disconnection for maybe 5 seconds. So I'll switch back to my usual network. Okay. All right. Can you hear me clearly? All right, so I'm back. I hope you are able to hear me clearly and see my screen clearly. Great, great. Okay, so the switching happened really quickly. Good. Now, what I'm trying to show you how to pass this test. It is asking me that it is asking me to create a Z node inside this, inside slash CloudX Lab. So I'll go to Zookeeper client, and on the Zookeeper client, I'll say create slash CloudX Lab slash Sandeep Giri space AHA exclamation this. This is what it's saying, right? It's saying create this. Okay. All right. Just give me a second. There was a mistake in this. Okay. Okay. So this is the format of the question. And here I go. So I have created my Z node, and I say, it says this is not right. So I have to say 9034, 9034, and done. Now I go back, I say I'm done, please check. See, do you see that? Since I have done it successfully, it has given me a tick. Thank you, Partha. Okay, so you can see that it does the evaluation properly, and it helps you do the hands-on uh, properly. Okay, so we have built the similar kind of tutorials for Linux and for other things, and we are in process of building similar tutorials for rest of the machine learning and AI, so that people can learn properly stepwise while these exercises are guiding them. Okay. All right, did they make sense to you here? Great, great. So it'll give me a tick. You can see that last result was successful. A question from SP, do we cover Impala? We do not cover Impala, and Impala is anyway kind of backend engine. So it wouldn't really, I mean, whatever we learn in Hive, you will be able to apply the same thing in Impala. Okay, great, wonderful. Now, a very important topic is coming up, and that topic is HDFS. Okay. Anoop's question is, Zookeeper is used to maintain server status? Yes, that's one of the use cases of Zookeeper. Okay, so you can, whenever you think about Zookeeper, think of it as like a central whiteboard on which people can write. A question from Anil, any self-paced sessions on Python? We are in process of doing that. Okay, as in most likely we'll launch a free Python course. We'll invite all of you for that, and then convert the same free sessions into the self-paced session. Okay. Yes, that data is maintained in the Z node. Great questions, Anoop and SB. All right. Should we start with HDFS, or do we have more questions on Zookeeper? A question from Anoop is, Znode is created by Zookeeper or the client? So for Zookeeper, everybody is client. Okay, for Zookeeper, everybody is client, like HBase is a client, your application would be a client, or HDFS is a client. Everybody is client for Zookeeper. That's why we have covered Zookeeper the first. because there is a dependency of other services on Zookeeper. Okay, Kafka is a client for Zookeeper. So whosoever wants to write on this whiteboard called Zookeeper, they connect to the Zookeeper and write to it. All right. So Anil's question is, how frequently is it used in real time? So anybody who is building a framework or an application which is which requires efficiency and coordination, they generally go for Zookeeper. But most of the people who are looking for analytics, processing of their existing data, they generally do not touch upon Zookeeper because they would mostly be using uh, existing services like MapReduce or Spark for their processing, or Hive or data frames. The analytics people, they will be generally using these services, and they would not build a coordination service. Okay. So we had a similar service at Amazon. It is called something else there. And what we did there was, since I built a framework which would run parallelly on multiple machines, that they needed to coordinate between all these machines so that my program does not hit the same URL twice. Okay. For that, we used our internal Zookeeper clone at Amazon. Okay. It comes by default if you're using either Cloudera or Hortonworks stack. Okay, it comes by default installed. A question from SP, how we use Zookeeper as a developer. Zookeeper gives you jar that you can include in your Java project and then call the APIs of that Java package and talk to the Zookeeper server using the Zookeeper client's API. Do it make sense, SP? A question from Anil, who will maintain Znode? Is it dev or admin? Okay, so very good question. So let me explain. So let's say you have Zookeeper. It has the whole structure of Znodes. Okay, Znode is kind of, you can think of Znode as a file, right? So any application that's using Zookeeper, they will create their own Znode or update a Znode and so on, right? So admin will not be maintaining Znodes. Znode does not mean physical machines. Here, the Znode makes you feel as if it's a node as in a particular machine. But here, Znode is nothing but data, nothing but like a file or a folder. Okay. So let's not confuse Znode with a node, because Znode is just a representation of data or file or a folder. Okay. Do I make sense, Anil? All right. Great set of questions. And all right, should we start with HDFS? So far we have understood the overview of big data. We have understood the overview of CloudX Lab, like how to connect and how to get started. And we have also learned a coordination service called Zookeeper. We also learned that there's something called election, and we've also learned what happens in various circumstances. All right, now let's start with the another foundation called HDFS, Hadoop Distributed File System. Okay, so in this, when we talked about Hadoop, there was something called Hadoop Distributed File System. That's the foundation of the entire Hadoop ecosystem. It's the main component, and we will talk about why we need it. Let's start with asking a very simple question. Okay, let's imagine that you don't know anything about Hadoop file system yet, and you are not allowed to use cloud storage. So if you have to store 100 terabyte of data reliably, then how would you store it? How would you build a storage system that can have 100 terabyte data? A storage system that could provide 100 terabyte of storage to your users. How would you do it? Yes? Give me a quick answer. Just ponder for a moment and then break it. Okay, go ahead, Sanjay. And we have to build it. We will not be kind of using off the shelf like NetApp. Yes, NetApp does it, but NetApp is little too costly for 100 terabyte data. So when when the guy when they were trying to create a crawler, right, the authors of Hadoop, they were trying to create a search engine. When they were trying to store this data from internet, they realized that they cannot use the usual file system, and they had to figure out how to build this humongous storage. And that's when HDFS has came in. HDFS, as in Google File System paper came in, and they built it. Now, question to you is, how would you build it? A question from Fakhruddin is that, okay, store copy on several machines. Good, good. SP saying keep the multiple copies of it. Good. And yes, use some sort of distributed system. Yes, that's what we should be doing. Any other suggestions? A little more details? Yes, thank you, Kiran. So yes, let's talk about that. So I think what Fakhruddin also means that it's a similar thing, store copies on several machines. Let's talk about that. Okay. So before this, newer file systems came into play at, say, at D Shaw, at other places, this is what we did. We built something called network attached storage, or sometimes there is another little bit more resilient version of the same thing. It's called storage area networks. Also, there is a third name for it, just bundle of disk, JBOD. Okay, so what we do is we take lots of drives, lots of computers having multiple drives, and we connect these computers to the network, and then mount these multiple drives to one or two computers such that each drive is a folder. Like in Windows, you can say you can map a network folder onto a local folder, right? Similarly, in the Linux, you can also mount faraway drive onto your local folder. So on a computer, they will all look like subfolders while they are pointing to a remote hard drive. Okay, is this architecture clear to you? So you take 100 drives, and all these 100 drives are connected to the computers, which are connected in the network, and you have mounted these drives as folders inside a main folder. Okay? So, is it clear? Do you see any challenges with this? Do you see any challenges with this? No challenges? Yes, each folder has some part of data. Great set of questions. All right. Yes. So Rakesh's point is no indexing. SP saying that what if there is a network failure? Wonderful. And there is no failover. There's no backup. That's right. Anything gets disconnected, what will happen then? Thank you, Nanu. And what if there is a loss of data and there is a latency issues. Wonderful. Handling hard drive failures will be difficult. Good, good. And the speed will be slow. Then how do the user communes to see the whole data? Okay. How does the user see the whole data? Correct. Okay. Yes. So question is, if there is one computer that's hosting this main folder, that could be a bottleneck, but then you can mount the same thing on another computer and can inform people that use both of these. Okay, but it's a very valid point. Wonderful, wonderful set of questions and set of answers. And anything else? I think you have covered all of these, so let's move on. So the first thing that you raised concern is, what about failovers and backups, right? In this model, if any of the machine goes down, you don't have a failover or a backup. But at this point, you may argue that we can set up something called RAID, R-A-I-D, redundant array of independent disks. So you can set up every drive, uh, a backup of every drive on the same machine, right? But again, that does not provide the failovers. Okay. Secondly, it does not protect you from network failures, because yes, we can protect ourselves against hard drive failures. We can protect ourselves against hard drive failures, but we cannot protect against the network failures using the RAID. Okay. So next question is, how do we distribute data uniformly? Okay, so one of the uh, friend who I was working with, they were handling some data with NASA, the National Defense one, and they had a similar model, and all the time the question remains, and the same was at Dish also, that we were always busy in transferring data from one folder to another. You remember the days when we had this computer with multiple drives, C colon, D colon, and E colon. We designated C colon for say movies and D colon for music. Now C colon got over very quickly, while D was still free. So you will start moving some data from C colon to D colon and so on, right? That's a story of our life when we were trying to manage the lot of data in our computers, right? So the same thing is also true here. Distributing data on multiple drives is impossible, right? That's why we always tend to have a single uniform system in which you could, if you start putting more data into one folder, it takes up the other space. Okay, right? Second is this the best use of resources, right? Because the data will not be uniformly distributed. Also, there could be many drives. You already be having many drives. Instead of buying up really costly big size drives, can we use our existing system, existing drives to give us the storage? Okay, if we, in this model, if we try to use smaller drives, what would happen is we would have too many drives and it won't work. Okay, next is, how do we handle frequent access to the files? Imagine in this model that there is Independence Day and everybody wants to watch a particular movie, right? So, or it's a birthday of some actor who is really popular and you would like to watch that movie. I mean, most of the people would like to watch that movie, meaning there is a single file that needs to be accessed. Let's say that file is existing on drive one and all the people want to access that particular file. Now that file being on single machine, what would happen is all of these people will end up crashing the drive, or all of these user requests will block each other, because a drive is a physical system. It is a mechanical system in which the header moves on the drive to read the data. Correct? Therefore, therefore, the, therefore, we won't be able to handle very frequent access to a particular file, because that file is located on one drive, and we might end up making that drive as bottleneck, right? The next one is, how do we scale out? What does it mean by scale out? Scale out means that today you need 100 terabyte storage. Tomorrow you might need 200 terabyte storage or 150 terabyte storage. In that case, can this solution scale out? Can this solution work out for you? Right? Do I make sense to you? Great. So what do we use? That's why the system like HDFS became popular. Okay, this is the existing model. I'll just take a brief overview of this one. So you have two kinds of nodes. One is called name node, other is called data nodes. Okay, name node maintains metadata, and data nodes store actual data. Name node maintains the metadata, and meaning which file is where, and it keeps the metadata in the memory. Okay, and data nodes are keeping the actual data. So instead of the way we had defined the cluster in which we have connected all these machines, we came up with a service. This service actually is doing the work. Okay, so we installed that. There are two kinds of services, meaning what is a service? A quick question is, what is a service? Service is a software component which keeps on running in the background, and you can communicate with this service using a network port, using a socket connection. Like there is a mail service, email service, and you can talk to email service using a port 110 and 25, right? Similarly, there's a web service like HTTP web service. When you open a browser, it connects to the web server, and the web server generally runs on 80 port or 443 port for HTTPS. Okay, so that's a service. In the similar way, we have two kind of services. One is called name node, other is called data node. Okay, name node maintains metadata. Okay, and rest of the nodes, which are called data nodes, store the actual data. So if you have, say, 5 computers, you will designate one computer for running name node, and while all five will run name node and data node. As a practice, we do run data node and name node on the same machine, but it's a better practice to let name node run individually, because name node is a little too intensive process. Therefore, we should not meddle with it. But in case of CloudX Lab, we have installed data node on the same machine as well that has name node. Okay. So we have here we have four machines on which data node is running and one machine on which name node is running. All right. So data storage actually storing the actual data, while right. A question is, does data replicated across data node? We are coming to that. Okay. So these are data node. Now, a quick overview of designs. HDFS has been designed to store very large files, streaming data access so that you can keep on reading the data really fast, and is done with You can create your own HDFS using commodity hardware. HDFS has limitations like low latency data access. HDFS has lots of small files. Sorry, sorry. Okay, so the design was HDFS design is to handle really large files. You want to access the data really fast by multiple machines, and you can use HDFS on commodity hardware. Commodity hardware does not mean defective hardware. Commodity hardware means a decent hardware in a good condition. All right. It's not like you need blade servers to run HDFS. You can run on a normal machine as well. Okay. Krishkant will talk about that one. It's a very good question, both of yours. Okay, good. Now, HDFS has limitations such as whenever you try to access data, there will be an initial lag. There will be a lag of few milliseconds. Okay, that may not be acceptable by multiple requirements. Okay, by some of the use cases that may not be acceptable. If your data is having really small file, what would happen is you will end up overflowing name node or overloading name node because name node is keeping everything, this metadata in the memory. More the files, more will be metadata, and therefore it's not great. So the way to handle is if you have really huge number of files, you will create a single file and then use that single file for processing. Okay. Now, third is if there are multiple writers to the file and you want to have arbitrary file modifications, then HDFS is not really a great solution. All right. Now, the another feature, another design construct of HDFS is blocks. Every file is split into a chunk of 128 MB block. Earlier, this 128 MB used to be 64 MB. Now it's 128. So imagine that you have a file of size 560 MB. How many blocks will there be? Quickly, everyone. Every file that you store in HDFS internally, it is split into chunks of 128 MB. You will create blocks out of files. Each block can be 128 MB. The last block would generally be smaller. That's right. There will be 5 blocks. Okay. There will be 5 blocks. First 4 will be 128 MB each, and the last one will be 48 MB. Okay. We'll do a little practical later on this point, so that you get, you can check what I'm saying, and you can believe on what we are actually doing here. Okay, so we'll show you the blocks of a really big file, and then you will get the idea. Okay, does it make sense to you? So the files are broken into small block. Why? So that you can fit really big files into small disks. Also, if you have cut the file into smaller chunks, the maximum space that can be left on a data node that can be left empty would be lesser than 128 MB. Okay, what's a block? Block is a chunk, right? When you split a file into the parts, each part is called block. Okay, so here there are 5 blocks. Okay, so a file is cut down into further smaller blocks. Each block is stored as a file locally on the local file system. All right, using the operating system's file system, each block is stored as a file, right? Criteria for selection of the name node would be, anybody quickly? What would be your criteria of selection of name node? Here it does not, one, if you are thinking like Zookeeper, the name node get selected, it does not. The administrator explicitly defined that this machine is the name node. And how would you define that? Why would an admin choose a particular machine for making it name node? The machine that's having the bigger RAM. Thank you, Ricky. And the machine that's having a bigger RAM or would be generally considered for the name node. All right, because name node keeps a copy of the entire data in the memory. Okay, great questions. Keep the questions coming. All right, so a huge file or each file in HDFS is cut internally into these blocks for the storage. The user never realized that every file is broken down into blocks. Okay, now the next question is, what's the additional advantage of block? Every block is replicated. Every block is replicated. It has multiple copies. Okay, it's called replication. Every block of the file is replicated, and the number of total copies, including the original, is called replication factor. And this replication factor is 3, meaning the total, if you are trying to store 1 gigabyte file, it will take 3 gigabyte space. Okay, if you're trying to save a 3 gigabyte, you're trying to upload a 1 gigabyte file on HDFS, then across the cluster, it will consume 3 gigabyte of storage. Okay. Okay. Very good question, Anup. We'll talk about it in a minute. Very good question. Now, there cannot be 2 copies of the same block. There cannot be 2 copies of the same block on the same machine. Okay. They cannot be. Why? The purpose of copy is defeated if we keep the 2 copies on the same machine. The purpose of copies is so that if one of the machine goes down, we have another copies to recover from. So if one of the data node fails, the lost blocks because of that data node will be recovered, right? So let's say this data node failed and some blocks have disappeared. But since we had a replication factor of 3, those blocks would be having copies on either of those. And let's say there was data node which was lost here and it has copied on first 3. So what would happen is a copy of that will be kept here as well, since this one has gone down. Okay, so if any of the data node fails, the lost blocks are recovered from existing nodes and their replication factor will be rebalanced or recovered, okay, by creating one more copy. All right, and this process happens automatically. We do not have to do it manually. So if any of the data node goes down, data node is just a machine, it could go down. The lost blocks or lost blocks cause the replication factor of those files to drop down to 1 minus, and then that automatically gets recovered by making the copy from the other copies. Okay, do I make sense at this point? It's just a little bit of theory, and then we'll do more of a practical, then it will make more sense to you. All right. All right. Now this, let me just okay, I think yeah. Let me answer your question. A question from Vijay: can we get more than 3 replication? Yes, we can set the replication factor to be more than 3. Okay. Another question is how are these blocks or replicas kept? There's something called replica placement policy. Okay. The default replication placement policy is as follows. That let me describe this architecture once. Okay. So imagine that you have data node 1, 2, and 3. Okay. And 4, 5, 6. These are the data nodes. Actually, numbering is wrong. Okay. So it should be, let me just fix it quickly. This is 3, and this is 4, and 5, and 6. Okay. All right. Imagine that you have a data center. Data center has 2 racks in this example. What is a rack? Rack is like an almirah on which you keep the computers. Rack is also like a local area network because rack comes with a LAN. What do you call it? The LAN rack comes with a router kind of model, whereby you each rack provides a socket for power as well as the network socket, so that all the computers get connected to the power using rack, as well as all the computers on the rack comes in a local area network. All right. So if there are 2 computers on the same rack, the communication will be faster than across the rack. Okay. So each rack behaves like a local area network. Now, imagine that you have 2 racks. Okay. Imagine that you have 2 racks, rack 1 and rack 2. Rack 1 contains 3 computers. These 3 computers are running data node process and data node 1, 2, and data node 3. And you are logged into data node 1. Okay, data node 1, e.cloudxlab.com, on which I am logged in, that's also a data node. Okay, so you can actually log in to one of the data nodes and start operation. So when you copy the file from your usual Unix file system into HDFS, what happens is the first copy of the data is capped on the same data node. Okay, the local data node. Second copy of it is capped on the same rack but different data node. Okay, the third copy is capped on a different rack, or we also call it off the rack. Okay, so the 3 copies, this is how the 3 copies are generally capped. Okay, the third copy defends against if there's a fire on rack 1, so the chances of second rack getting fire is lower. Also, if the router of rack 1 goes down, we will at least have the 1 copy available. Next is why it's capped on the same rack. If you're trying to process data here, and this data node goes down, we have the data available nearby. That's why first copy is kept very closer and second copy is kept little farther. A question from Sanjay, how are these connected? They're all connected in a network, TCP IP connection or local area network. Rack 1 and Rack 2 are connected to another router, and that's how it's connected. So this is one local area network, this is another local area network. They are connected through a router and form a network. Okay. So every data node is a server containing, they are addressable using a unique IP address, which can be connected from anywhere in the network. All right. So with respect to the replication factor, the default and recommended replication factor is 3. It can be set for the entire HDFS. The default value is generally 3. We can change it, the default value, to something else. It can be set for individual files. So the administrator can change for the entire HDFS, while you can change it for your own file. Okay. For not so important file, you can decrease the replication factor, and for very important files, you can increase the replication factor. But my strong advice would be to keep at least 3, right? Because if you think about HDFS, right, since the file is cut into blocks, if any of the block disappears, the whole file is useless. So by breaking the file into blocks, and if a node that is having the block disappears, the whole file is useless. So, and the files, the blocks of a file will be distributed in the cluster. Right? Therefore, if one node goes down and there is particular file which is having a replication factor of 1, and that one has kept a copy of, that one has kept one of the blocks on this node which has gone down, the chances of data corruption is higher. Okay, so usually we generally keep a copy of 2 in our normal file systems, but since we are cutting the file into blocks, HDFS becomes relatively more riskier, right? Because if any of the blocks goes down, the probability of losing data is very higher. Okay, therefore it's very advisable to keep the backup or the default replication factor as 3 or more. Okay, all right. A question from Ricky is, the HDFS is smart enough to recognize nodes in the same rack or another rack? Very good question, Ricky. Here, it does not. It does not. Unlike the systems like MongoDB and Zookeeper, where they try to measure the distance between the nodes based on the time taken to ping each other. In most of the other distributed systems, in some of the distributed systems, they keep on pinging each other and keep on noting the time it takes to reach that data packet between the machine, and that's how most of the other systems, some of the other systems actually, keep track of how far are the nodes. Okay, in case of HDFS, you have to explicitly configure that these are my racks and these are the nodes located on this rack. You can also programmatically configure that by mapping range of IP addresses to the racks. Okay, or can write a script which can do that for you. I'll cover it briefly. Okay, another question is, what exactly happens if one of the machines go down? Imagine that you had 4 machines. If you had 4 machines like this, right, and first 3 machines are having the copy of your block. Let's say this is the original block. These are the replicas of the block. Okay. Now, let's say this machine goes down. This machine goes down and this block has disappeared. So what would happen is name node would inform one of the data node like this one to start copying the lost block from existing one. Okay, so name node will inform or command the data node which does not have the copy of the file to take a copy of this replica and keep it with them so that the block recovers. So this way the block has recovered and is having one more copy. Does it make sense? Okay. Question from Sanjay. What if 2 machines go down? Let's say this went down and this went down. Okay, what will happen? Right? At this point, the the system will keep on giving warnings that these many nodes, these many blocks are under replicated. Okay, very good question. What happens, let's say, question from Kiran. Let's say, let's say that after a while this one was getting copied, at the same time, this one came back. Okay, came back. So what will happen here? Okay, what will happen is that it will check the checksum of the block. And if the checksum is same, what's a checksum? It's a signature of a file. Okay, a signature of file can be computed using either MD5 algorithm or SHA-1 or SHA-2 algorithm. So based on the checksum, it will check whether the file is same and it's good enough. Then it won't copy on the new one and resume the previous one. Okay. But if it has finished already replicating and there's a confirmation from the node that it has been copied successfully, then it would discard this node if it comes back in future. It will basically discard those blocks which have already been replicated. Yes. So all the not all the blocks will get replicated, Partha. Question from Partha is, will all of the blocks of a file will get replicated? No, only the blocks that are lost here. As we discussed that the block of files could be located on multiple machines. Just that two copies will never be on the same machine. They'll be on different machines. Okay. So whatever gets lost here, only those blocks will be recovered from existing machine. Good question. A question from Pawan. Is any concept of primary and replica block here? Basically, HDFS does not differentiate much between primary and replica, meaning the 0th copy, it does not differentiate much. It just says that these are all replicas. Okay. And there's no such concept like leader or follower, as we discussed earlier. Okay. A question from Kiran. What happens to the data that was on node 1? Okay. Will that be deleted or discarded after the full copy is done? So this node is anyway not in the network right now. But if it comes in the future, comes back in the future, the data will be discarded. Okay. That data will be discarded. And if that data has already been copied. A question from Krishnakant, who verifies the checksum of files? Okay, so name node orders these nodes to compute the checksums and then let them compare each other. Okay, but the process is started from the name node. Name node orders them. A question from Anil, is there any preference for blocks during read? Very good question again. So is there any preference for blocks during read? When you are trying to read data from here, is there a preference? So generally, most of the compute engines, take care of executing their logic nearer to the data. Okay. Also, when you are trying to access the file, you will be given, if you, let's say you want to create your own file system, then what it will do is you could actually create that mechanism such that the file gets copied from the nearer one, while the default library provided by Hadoop to you has all those functionalities. It will give you the copy of the data from local node, okay, if it is there. Otherwise, it'll give you the copy from the same rack. Otherwise, it'll give you the copy from across the rack. So yes, during the read, it does take your location in consideration. Okay, it is rack aware. Okay, all right. So do you want to take a look at it? And I think I'll just skip ahead. It's just too much of theory and you might get sleepy. Instead of that, I'll just do a little bit practical and jump ahead a bit. Okay, so let me just do a little bit hands-on and we can come back to theory again. Does it make sense to you? It's better to do theory before it's better to do practical before theory. Okay, all right, let's start copying the data. Okay, so here it's an important part to understand. Okay, so there are three machines in the play. Okay, your laptop. Okay, this is your laptop. Okay, your laptop. Then the HDFS, and third one is Linux console. Okay, I'll show you all three. So when I open this terminal, this is my Mac computer. Okay, if you see, this is my home folder. PWD is giving me present working directory. So it's showing that this is my laptop. Okay, now this is one machine. The second one is this file system. Okay, this is e.cloudxlab. Okay, and the HDFS is in Hue. Are you able to log in into Hue? Click on Hue under lab credentials in your MyLab. Log in into CloudX Lab, click on MyLab, click on lab credentials, and there you will find Hue. Okay? When you click on File Browser, you will see HDFS. Okay? Are you able to see that? So Sanjay is able to see. So you can raise your hand as soon as you are able to log in into Hue, as well as on the console. Great, great. All right. So Nitin, Partha, and Rakesh and Sanjay are able to log in into the Hue. So you log in into CloudX Lab, go to cloudxlab.com, click on login, and then click on My Lab. There, after you click on My Lab, in this, you click on Lab Credentials, and then you see login here, password here, and click on Hue. Okay. After you click on Hue, it'll ask you to give the login password, and that's it. So Ambari is the machine that gives you the overview. Let me show you Ambari also. Okay, you can log in if you want into Ambari also. All right, are you done? Great. So I'm going to show you Ambari from administrator's perspective. That will also give you a little bit idea. But before that, I'll just show you the file transfer between multiple machines. That's okay, Rakesh. All right. So you got three file system. One is this file browser. Okay. Second is the web console. When you say ls here or pwd here, this is third one. And this is second one. And third one is your laptop or desktop. That could be Windows or Mac or Linux. And this. Okay. So coming back to the point. Uh, okay. So this is HDFS. What you see here is HDFS. All right. So you can directly upload data into HDFS using upload here. Okay, I'm just going to go to my downloads folder and upload something here. Okay, let's say this file, which is 2.4 MB, or should I upload something else? A text file could have been a better idea. Never mind. So I can actually upload a file such as this one directly into HDFS. You see? So the file name is machine learning with MLlib, machine learning with Spark, MLlib. That's what I've uploaded. You can also try to upload the file into HDFS directly. Okay. So this is how we can upload data into HDFS. All right. So it has successfully uploaded the file here. Okay. You can see this is that file. Okay. A question from Rakesh. How did we got here? I went to CloudX Lab. Okay. Clicked on my lab, clicked on lab credentials, and then clicked on Hue. Or you can directly say d.cloudxlab file browser, and that's it. You could say this, not this. Um, you could say this. Okay. Don't worry about Ambari. We'll talk about it later. Okay, let's take a break for 10 minutes and come back. All right, so should we start? I'm back. Okay, so we were able to upload some data onto HDFS. Is everybody able to? Okay, let me just close everything. Okay, so let me even close this. So I opened cloudxlab.com. Okay, then clicked on my lab. Under lab credentials, we get this login password and everything. Then clicked on Hue. Okay, so Hue is a general, the web-based client to most of the Hadoop services, say Hive, Pig, and everything. So you can, it's by Cloudera. It's not really a part of Hadoop, but it's a web-based interface to access these services. So here we go. We clicked on File Browser, and then using Upload button, Upload files, we can upload any kind of data. Okay. Yes, is that good? Sanjay's question is, do we do this in the production environment also? Okay. The quick answer is not really. Okay. Yes, I'll describe to you. So this is the direct way of uploading from local laptop, from your laptop to here. Okay, that's what we did. If you have on your own laptop, this is what you can do. Now, going back to the console, this is our Linux console, e.cloudxlab. This is one of the data nodes. Okay, from here, I can communicate with Hadoop using Hadoop FS command. Okay, to take a look at various commands provided by Hadoop FS, okay, we have these many commands. Okay, we have commands like append to file, cat, checksum, change group, change mode, change owner. Just like Unix, we can also do the permissioning and change of permissions on HDFS. Okay, just like Linux. Now, we can say Hadoop FS copy to local. Okay, and what was my file name? My file name was, so we have just copied a file from my laptop to the HDFS. This is HDFS. You see, /user/sandeepgiri9034. That's my home directory in HDFS. Now, I can copy this to my local machine, okay, by saying, not like this. Okay, here I could say machine asterisk to local. Okay, so it has copied this file here. Okay, so you can, all right, so you can take a look at it. Handouts is actually, this whole PDF is available to you in the assessment. Okay. All right. Now coming back to it. So I was able to copy the data first from my laptop to directly HDFS using Hue. This is what we did. We uploaded. This is the thing which we did just now. Okay. So let me just make it this. It looks really horrible. So this is what we did just now. Then we use Hadoop FS to copy data from HDFS to my CloudX Lab console. Okay, this is what we just did. Okay, and this one is something that requires you to install the you to install the any of these clients. Okay. So first of all, I went to HDFS. Are you able to open this, Beatrice? Are you able to open Hue? And I uploaded a file. Then went to the file browser here. And inside that, I clicked on upload and uploaded a file there. Okay. So click on file browser in the Hue, click on upload and select files and then select file. It's up to you. Do not upload any private data. All right. Great. So this diagram is something you keep in mind. So there is a laptop. From laptop, you upload it to HDFS using Hue, right? Now from HDFS, if you want to go to copy the data to or from the CloudX Lab Linux console, we could use Hadoop FS command. Okay, so I went here and said Hadoop FS -ls -ls to see the list of files, and then I said copy to local. Local means this machine, this Linux machine called e.cloudxlab. It will copy the data from HDFS to the local machine. Okay, so I'm just copying it again. Okay, you can provide asterisk so that it auto completes. So it says that it is already existing. Okay, let's say I rename this file. Okay, I just say I'm a lib.pdf. Okay, how do you rename in Linux? You can use mv command and give the first file name followed by second file name. Okay, and when you press tab, it auto completes the file names. Okay, so I've just renamed this file locally, but this file already exists in the HDFS. Okay, so I can further interact with HDFS and say delete, okay, and give the name of the file. Sorry, it has to be rm, not delete, rm. So I'm deleting this file from my home directory. When we provide the path with starting with slash, it means absolute directory. Here, when we are not providing path starting with slash, that means we are talking about the file in our home directory in HDFS. Okay, this means we are trying to delete all the files starting with machine with capital M, and we are trying to delete all those files, right? This is what it means. We are trying to delete all the files with the name machine asterisk from our HDFS home directory. What's my home directory? /user /sandeepgiri9034 in HDFS, and in the e.cloudxlab, my home directory is /home sandeepgiri9034. Okay, so I got two home directory, one on this machine, e.cloudxlab, that's the Linux machine, and also I got a home directory in HDFS. Okay, so right now I've just deleted my old file from HDFS, and let me upload a new file, same file but different name, which I renamed. So I'm just saying Hadoop FS copy from local MLA. Okay, now I'll show you. So when I go back here, if I refresh this, is there a refresh button somewhere? Yes, it's always better to mention the absolute path instead of putting asterisk. That's right. But since my path had spaces, it was, prone to errors. Okay, right now the file is not there anymore. You can see. The other way to search file is just search for ML, search in this box. Okay, and this box does not auto clear up, and that causes a lot of mistake. You keep on wondering what happened to my files. Okay, so you always clear up this box. Now, right now that file is not here, so I'm uploading this file back from Linux console. So what I'm trying to do is copy, copy from local. This is local, and I'm copying from it to HDFS. So I'm saying Hadoop FS space dash copy from local, and I have given this path. Hadoop FS copy from local and this PDF. Now, this file would appear in HDFS, and how do we take a look at HDFS? Using Hue directly. Okay, you can see it has MLlib PDF. Okay, so you can directly also see the presentation of MLlib. Okay, a question from Rakesh: can Hadoop FS be used for any LX command? Not really, only these commands. Good point, but it only provides you these commands. Hadoop FS dash help. So you can take a look at all the commands. These are the commands using which you can talk to HDFS from the Linux console. Okay, this command is what you're going to use in the production environment. All right, so let me just go over all the commands provided by Hadoop file system. Okay, append to file. Let's say you have a small file, you want to append this small file to a file lying in HDFS. Okay, this is the case where, let's say, you're generating log file continuously on a particular host, and you want to keep appending that log file to a file existing in HDFS. Then you can use append to file. Okay, second is cat. Let's say there is a file in HDFS that you want to take a look at. So you can say cat, and the entire file will come locally. Okay, the second is checksum. What did checksum do? Checksum basically computes the checksum that I talked about. Every file, I mean, it's a cryptographical checksum, either MD5 or SHA-1. Okay. If you want to change the permission, then you can use chgroup. And chgroup is to change the group ownership of your file, same as Unix groups. Chmod is same permissioning as Unix. In HDFS, chowner is owner of your file. Be careful with owner. All right. Generally, chmod, chgroup, and chown are used by admins. Um, So the HDFS does not have an interactive shell like Zookeeper client did. Here, it's basically a Unix command. Okay, you have to say Hadoop space fs, then followed by one of these commands. All right. Say, for example, I want to take a look at Hadoop fs-ls. I want to take a look at my HDFS directory. This is my HDFS directory. Okay. So you can take a look at, all right. You can take a look at this. A question from Beatrice. What are the cautions using with owner? Basically, owner and ch group might give your permission to somebody else, but these are not allowed generally for every user, so don't bother about it. Okay, generally the root can do that. So Hadoop FS talks to the Hadoop. Hadoop FS talks to the HDFS. Hadoop FS space copy from local takes from my Linux machine to HDFS, and copy to local brings the file from HDFS to this Linux machine. Okay. All right. So you put double quotes around your file name because your file has spaces in it. Or you can simply say TJ100ME asterisk. All right. I'm talking to Sanjay. Sanjay has posted an error. So you could say things like, because the file has spaces just like mine. So you could, all right. So does this file exist in your Linux console or is it existing in Hue in HDFS? If you're trying to bring it from Hue to local, then you can say copy to local instead of copy from local. There's no PWD command in HDFS because you can't really persist the change in directory. Okay, so you can use the command I've suggested you, Sanjay. You can say copy from local and use asterisk or use double quotes around the file name. Okay, or let just type first letter and let HDFS try to complete it. A question is, when we are copying data from local to HDFS, where is it copied? It is copied to your home folder by default. Okay, I'll show you. You can also say things like help, and against every command, you can say like this. Okay, so you can also use get instead of copy to local. Okay, all right. So Sanjay, can I take a look at your screen if that's okay with others? No worries. I mean, this is an important part because what would happen is whether we are running Spark, whether we are running anything, we will be handling the data stored in HDFS. Okay, so just give me a second. All right, go ahead. Say ls, say ls, just say normal ls. Good. So you're trying to upload that. Okay. So Hadoop fs copy from local. or just copy paste the file, put the double quotes around it. All right. Just remove asterisk, press tab, enter. Unexpected URI syntax exception. Interesting. Interesting. I'm seeing this error for the first time. Could you do this? Just rename it. Do MV, and just take and put some other name. Say TJ only. .pdf. Interesting. This is the error I'm seeing for the first time. Now try the same thing. Now it worked. Probably one of the characters are not in ASCII in the file name earlier. That might have caused this issue. Okay. This is something which I've seen for the first time. Wonderful. So now it would appear in your hue. Can you just go to hue? The fifth tab here in this browser. The fifth tab. Next, fifth tab in this browser. After my lab.
Hello.
Yeah.
Yeah, I cannot remove this. I mean, there is an option about this. It's pause, share, participant. So I cannot see that tab.
I see. I see. Just what I'll do is I'll just share mine once, and then you can share again probably. Now you can share again. Are you able to do it?
Yeah.
All right. So probably everybody is able to understand these 3, 4 things. Okay. Show me the Chrome. We cannot see that. We are seeing your Outlook.
This is Hoy, right? File system.
I know actually you shared the Outlook with us.
Oh, is it? Okay.
Yeah, yeah. Yes. All right. Okay. Yeah. Yeah. This is where just refresh it. Refresh it. All right. So you see that there is a TJ.
Yeah, yeah.
Great, great. I hope that everybody got the picture as in how to. Okay. Okay, so we were able to do the hands-on, whereby we first copied a file from our laptop to HDFS, and then copied from HDFS to our Linux console. Then we renamed the file and copied back from our Linux console onto HDFS. Okay, the third part, as in, not this one, the third part, this part, I'm leaving it up to you to install WinSCP and SFTP. So you install, if you're on Windows, you can install WinSCP. Otherwise, you can use directly if your laptop is having, say, Linux or Mac, you can use SCP to copy back and forth between Linux and this laptop and the Linux console easily using SCP command. Okay, so that is very straightforward. But if you are used to using FTP client, you can simply use those FTP client, provide your login password, and use SSH SCP file copying over SCP. All right, you can mute yourself, Sanjay. Thank you. Great. Now, okay, so I hope everybody got a picture. All right. Now, this is one home folder we have, right? We have also provided you with a lot of data sets. One data set is in slash data. Okay. This data set we'll be using over during the class. And so we have some data sets for Pig, some for Spark, some for Scoop, some for sentiment analysis project, some for Uzi. This is a movie lens project. This is for say Flume project, and we have the sentiment files again. There's some data for New York Stock Exchange and so on. The other comprehensive one is here, this data set. Here there is some data set for streaming and Reddit comments and so on, right? A question from Krishnakant. What's the difference between HDFS? HDFS is the one which we discussed that has name node and data nodes, while CloudX Lab Linux console is the standard Linux file system. Okay. Linux file system is the native file system on which actually the data is stored. This file, for example, enron underscore mail dot tar dot gz, it is actually broken into blocks. Okay, it is broken into blocks and it'll be stored on multiple machines. Okay, so this you can access via slash datasets and so on. Okay, so I just wanted to give you the overview of what we have in HDFS. Now coming back to question from SP, what's the difference between HDFS, DFS, and Hadoop FS? HDFS, DFS is a newer alias to the same Hadoop FS. Okay. HDFS, DFS also is equivalent of Hadoop FS. Hadoop FS, in fact, redirect you to internally, redirect you to HDFS, DFS. Good point. Okay. So all right, so here we are able to see the list of files and so on. Okay. Now, if you want to take a look at, no, the folders that I was showing you are accessible for everybody. These are read-only folders. Okay, read-only folders. You cannot change anything here. Okay, you'll have to go to the top level by clicking on top slash and then data. Okay. All right, so that was our quick way to look at it. Now, there is a next command to take a look at HDFS files. Okay, before I jump to this, let me show you one interesting file. Okay, so are you able to see? Hue is for accessing most of the Hadoop services. You can also use Hadoop FS instead of Hue. Okay, so but it's a browser way of looking at Hue, looking at HDFS. Now, do you see this in underscore table inside data MS project? How big is it? Do you see? It's 7.7 gigabyte. Okay, I'll show you from the console. I want to show you something interesting. Data slash MS projects. Okay, you see how big is this file? Okay, so can somebody guess how many blocks will be there in this file? Quickly. We can use a BC here, this divided by 128 into 24 into 1024, these many bytes, right? So approximately 61 blocks. It'll be actually 62 in my opinion, because no, this is wrong. I'll use Python quickly for my calculation. Yes, this is correct. You see, 61 point something, right? That means there'll be total 62 blocks. Did you get an idea? So when we said Hadoop fs my dash ls in this folder, we got the listing of this file and its size is this much. So we divided that with 128 MB and we got this. That means there will be how many? 62 blocks, right? Because we can't have 0.86 size block. The last one will be these many. Last one will be having these many bytes. Okay? Or you can say point, no, actually more than that. Last one will be having these many bytes. Okay? Last one will be 110 megabyte. Good. Is everybody okay with this? Now, let's actually check that our hypothesis is correct or not. We can take a look at any file system using this. Okay? Using this. So what's our location? It's in MS. Okay. All right. All right. So these are the data blocks that you want to see. If you is anybody interested, then you can take a look at it here. So we are saying HDFS, FSCK, file system check, show me the blocks, show me their locations, also show me their recs and show me the files. Okay, that's what we are saying. And let's take a look at it. What's going on? So what you see here is an interesting part. So it says there are 62 blocks. Okay, so our hypothesis was correct. All right, so these are the block IDs. Okay, every block is essentially every block is essentially a file underneath. Hadoop FS does not autocomplete. Okay, so you can see this is essentially the block report. Okay, so you can see that it is showing us that the replication factor of each block is this much. And it is located in this rack, default rack. Right now, we have not configured rack in case of HDFS, in case of Hadoop. Therefore, it is showing that default rack slash this, that's the name. And this data node is running at this particular port, 50010, as well as the second copy of the same block is at this place. You see, this is the second copy. This is the third copy of the block. So it's the same block ID, but located on 3 different machines. Okay. Similarly, all these blocks are copied to different machines. You can see this is on 3742, this was on 60, and so on. Okay. No, actually the ordering is different, just but the data exists in these many blocks. Okay. A question is there a way to take a look at nodes? Yes, you can say, you can take a look at it here. This is the name node probably. Okay, I'll show you what do I mean by name node. Let me go to Ambari. Okay, I'll show you. In Ambari, when you click on HDFS, please take, I'm okay if you do it with me, because that's the right way to understand it. Okay, in HDFS, if you select, there is the name node. Okay, name node is this. You see, IP address is 172.31.53.48, right? And this is the same IP address, correct? 53.48, 53.48. Okay. A question is, can we know the date time of block creation? That I'm not sure, because individual block might be created from different times. So I'm not sure how you can check that. Okay. Although you can check the file date time from the HDFS. Good. So here is the report. It says the status of the file is healthy. Total blocks available are these. And the default replication factor was 3, and the current average block replication is this. What is average block replication? Every block, we sum up the total copies of block, divide by the total number of blocks. That's the average block replication. It should be equal to default replication factor in order to have the right uh, size. There is no missing replicas. Okay, and these many data nodes are available. There is one rack. Okay, so that should help you understand what does it mean by, what does it really work? All right, so every block has got an ID, and generally the data of blocks is stored here probably. Let me just show you. Since every machine is running a block, let me just show you these data nodes. If you click on data nodes in HDFS, so you see these are the various machines that are having data node. Okay, including e.cloudxlab. E.cloudxlab is from IP mappings. E.cloudxlab is 60.179, right? 60.179, and 60.179 is having, yeah, it is having the data node, correct? So every machine is having the data node. Okay, and if you go to /Hadoop, okay, this is where it generally keeps the data. Okay, so I'm going into this. So there you will find one file for each block located on the data node. Okay, so you can say current, and under this, if you say BP, and you, okay. So if you say again, there's a huge hierarchy of raw data. This is actually how the HDFS is storing the actual block. Okay, so you can see that it has created some random files. So yeah. Okay, so you can always locate the blocks. These are the raw blocks of data that it has kept. Good. So this was the question from Fakhruddin. So that's what I was answering. Good. So we were able to take a look at the file. Yes, maintenance of the name node, data node is part of admin role. All right, great. All right. Also, we can change the replication factor using this kind of file. Okay. So whatever file I created, I'm going to modify its replication factor. Okay. So I'm going to say cd enter. That means I go back to my home directory. Okay. And I say Hadoop FS. And what was my file name? The file name was slash user slash Sandeep Giri 9034 slash mllib.pdf. Okay, so I have reduced its mllib's the total number of replication factor. Now, if I call the same HDFS report, I would be able to see that the block size has reduced. Okay, the not block size, sorry, the replica set has been reduced. So you can see average block replication is 1. Okay, though the file system's overall replication factor is this. Also, you can see that here there is only one copy, replication 1, and there is only one node holding the block. Okay, but if I say things like replication factor 10, what would happen? Anybody? There are only 7 nodes or 6 nodes available. And what would happen if I put replication as 10? So I'm saying W minus W means it will wait till it happens. Okay, so it'll keep on waiting. If I don't put W there, okay, if I don't put W there, it won't wait for it to finish and return immediately. Okay, so replication has been set to 10, but that will never happen. Okay, that will never happen. I'll show you. So I've set the replication as 10. Let's see what happens here. Okay, so here it says replication 7, you see? Yeah, it's kind of sync async. Okay, so it won't go beyond that. Here you can see target replica is 10, but found only 7. Okay, because we cannot set more than 7 because 7 is the maximum number of machines. Okay, can every task of Hadoop FS be achieved with HDFS FSCK? No, it will be achieved with FSCK DFS. Okay, HDFS DFS is equivalent of Hadoop FS. So W means it will wait till the work has finished. Okay. Great. So we are able to talk to HDFS from console. Now we will go back to the discussion. All right, great. Is everybody awake or? Great. So let's talk about the further details of Hadoop. So whatever we have learned so far is actually more than enough for most of the working. Okay, most of the working that we'll see during data churning, data processing, we should be comfortable in data copying from here to there, taking care of our replication factor, and also scanning through the file system. Okay, now question to you is, somebody has asked this question and I had ignored this question. Who breaks the file into blocks? Okay, it's a good question and I ignored that. All right, I kind of thought that I'll reply. Good. I think Ricky has asked to somebody. All right. So who breaks the data into blocks? Who breaks the data into blocks? So it is the Hadoop FS command. Hadoop FS was the client. Okay. So although you were the client, but you were using Hadoop FS command. So Hadoop FS is the driver or the client. If you are using if you're using, let's say, some third-party driver, then that one will take care of breaking the file into blocks. Now let's try to understand how does the conversation goes. So when the when the user wants to talk to Hadoop, they use the client called Hadoop FS or SDFS DFS or some custom command like custom program like Hue, which internally uses Hadoop FS. Now the client talks to the name node and name node gives back the data, metadata, right? Name node gives back the data. Name node does not give back the file, please note. So name node gives back only the metadata. What is metadata? The name of the file, the size of the file, the permissions of the file, and number of data blocks, the data blocks IDs, and which machines they access. That's metadata. That's not actual data, right? So whatever is in the memory, name node instantaneously replies with that. Okay, this metadata is in the memory of name node. It just replies that. The client, based on this metadata, locates which data node it needs to go to for fetching which block. It's up to this driver whether to read all the blocks parallelly at the same time or read the data sequentially. Okay? If you want to build your high performance system, you can such that it should be really fast. So what you can do is you can actually read the data from all the blocks from all the machines simultaneously, right? And also locate the data node which is nearer, right? Namenode is not a zookeeper implementation. Namenode does keep some bits of information in zookeeper. We'll talk about that. That's called high availability setup. Very good question, Ricky. So question is, how is access credentials taken care of considering there are multiple servers? How does the client securely access the data node? So most of these clients are located on HDFS. Okay, they are located on Linux. So this user is actually a Unix user here, but they can also access name node directly over the network. And you can in the name node, you can actually set up the security as well as on the data node, you can set up the security provided by HDFS. Okay, so that you can provide login password and access this file. All right. So the login password that has been provided to you, using that, your client can read from name node. Right? If you are on Hadoop Linux file system, then the identity provided by Linux file system should be parallel to what is provided by Hadoop file system. And that's how the whole machinery works. Great set of questions. Now, the client can directly will go to the data directly to the data node and will access that. There could be many clients doing the same thing and so on. Is it clear to everyone? It's a very important design. In classic sense, what we do generally, we create this facade which will internally talk to data node and return. But no, if that was the case, if data node starts reading on your behalf, if name node starts reading the data on your behalf, name node will become the bottleneck, and therefore it'll become impossible to use name node. Therefore, name node does not give you the data, it just gives you the pointer to the data, and then using that pointer you can actually access the data from data node. Now, question is why there is a single name node. Had there been multiple name node, what would happen is, imagine that two users are trying to create the same file. First one went to one name node and other went to the second name node. Then what will happen is when they both try to talk to data node, they will end up overriding the data. Okay, there will be a conflict. So the anatomy of file write looks like this. HDFS client Hadoop FS, for example, talks to the file system libraries, and then those libraries talk to the name node, and name node creates a temporary file, kind of a dirty write, and then it tells the client, it tells the DFS, it tells the file system that go to data node and write there. Now the client goes to the data node and starts writing the blocks. The first copy generally goes to the same machine on which Hadoop FS is running, and then the copying of data between data node starts happening there. Okay, so this is what happens. Similar is the case with read. The client goes to the name node returns the block location, and then using those block location, HDFS can read from the data node. The Hadoop HDFS, DFS, or Hadoop FS can read from the corresponding data node. This is what happens while reading the data. Okay, now then what happens next is the name node is keeping metadata in memory. How does it work? Okay, all right, let me explain this. I think I missed a couple of things. Okay, going back to the right, let me answer Rakesh's question. So it won't confirm anything to the client until the entire application is completed. Not really. Not really. The replication will keep on going in background. As soon as the first copy is written to the data node, confirmation is sent to the name node. Okay. So as soon as first copy is done on the data node, the confirmation is sent to name node that it is done. Okay. Great. Thank you, Anil. And yes. So although the diagram looks like that uh, all of this is happening in fourth step, but no, that's happening actually parallelly. Okay, that's the reason why it makes the first copy local, so that as soon as possible the first copy is written to the Hadoop one of the data nodes, so that the rest of the copying can happen in the background. To reduce the latency of writing, the first copy is generally written on the same machine on which the Hadoop FS is being run. Okay. Now, once that happens, once the data node, one of the data node confirms that I am done, then the Hadoop FS command goes to name node and informs that I am done. Okay. At this point of time, name node commits the changes. If the Hadoop FS command is not able to confirm to the name node that I am done, until that point of time, name node does not commit the file. Okay. Question is, where is the data being broken here? So at this point, when the client said to name node that I have got this big file and I would like to create that file, name node will say that yes, great, you want to create the file. Here are the data node IDs. Go to 4 of the data nodes. These are the block IDs. Go and create there these blocks. Okay, put the data. So the Hadoop FS command will break the file into blocks and will start writing those blocks onto various data node. Okay, and it will not really break it. What it will do is it'll basically offset into the file. It will start reading the file from left to right. And as soon as it has completed 128 byte of reading, it'll give that block to one of the data node, and then second, then third. Okay, that's how it'll do. All right, did I make sense to you? All right, similarly, assembling is done by Hadoop FS. Hadoop FS will get various blocks of files from the data nodes, and it will assemble those blocks and give you the concatenated result. Okay, now, any chance of block getting corrupt? Yes, there is very much chance of block getting corrupt. That's why after writing, it would confirm with the MD5 checksum, and only then the acknowledgement of successful write is considered. Okay, so that's a part of protocol when it's sending the file or parts of the data. Okay, very great set of questions. It's a part of protocol that whenever A process is sending the file to B and B is trying to write, generally the B confirms with the MD5 checksum, and then it compares that is the checksum same as what we had written. If those are same, that means it has been successfully written. Okay. Question from Partha is, if the write is happening on multiple data node, how come one data node can confirm the write is complete? So in this example, when we were talking, we were considering there was only one data block. Okay, only writing is happening only on one data node. Okay, replication is happening to others. Okay, but in certain circumstances, maybe the first block is going to this one, second block is going somewhere else. And so in those cases, there will be multiple writes. And only when all those, if the file is bigger than 128 MB, there will be 2 blocks, right? Two primary blocks, each block having 3 copies each, right? And therefore, here at that point, it will try to write those 2 blocks to this data node. If it got the instruction that keep first block here and second block somewhere else, in that case, unless both the data nodes give the confirmation that these blocks have been successfully written, it would not confirm to name node. Okay, that's how it happens. Very good question. Okay, so checksum is not sent from one data node to another data node. It's the actual data that's sent. And replication is considered completed only if the node, let's say here the replication is happening from here. So until this confirms back saying this is the MD5 checksum of the written data, it won't be considered that this replication is successful. Same is the case here. Okay, so any write is acknowledged with the MD5 checksum. A question from Prasant. While writing block to a data node, step number 4, what if data node goes down, right? Good question. In that case, first, Hadoop FS, the driver will try to write to some other node, okay, which name node must have given it a list that you can write to any of these. If that doesn't work out, so it basically shows that unable to write file and does not give a confirmation. The 7th step does not get completed. And the temporary file that name node has created in step number 2, it will, after a point of time, it will expire that. Okay. Let's say at this point of time, Hadoop FS was writing to here and both of them crashed. It did not get time to say complete to name node. In that cases, the file will, the temporary slot that it has created will disappear after a point of time. All right, good, very good set of questions. A question from Pavan regarding the installation. Do we need installation on every data node and name node? Some details on installation, please. Good, good. I think it's the right time to talk about it. All right. So I think, although it's part of admin, I would like to give you the quick overview. Okay. Okay. So the general strategy of installation is install on one. Okay. You install Hadoop on one, install Hadoop on two, and give them the list of IP addresses by the way of configuration that this is the data node, this is the, and all of those. So there are, all of these come as a service, so you can start the file system on all of these after providing the information about name node and data node in the file. Okay, this is the theoretical way of looking at the installation. In practical way, you either use Ambari. Okay, you either use Ambari or use Cloudera Manager. Okay, Ambari is from Hortonworks, Cloudera Manager is from Cloudera. These are provisioning manager. Okay, so what happens is Ambari basically you install Ambari server on one machine, okay, the web server, so that you get this nice interface, and then install Ambari agents on every machine in the network. Okay, now access Ambari server from the browser. Okay, and then start adding those machines to the network on which you have installed agents. Okay, this is how we have set up CloudX Lab. If you are trying to do the same thing, you can do the same thing. So what you do is you install Ambari server on one machine and then install Ambari agent on every machine in the network. Then go to the Ambari server from the browser the way we are accessing right now. This one, it gives us It gives us this ability to add more and more hosts. So you could go to the host and start adding new hosts. Give the IP address of all the hosts and confirm. And at one of the stages, it will ask you which services do you want to install on this particular machine or these new machines. Okay, and what kind of configuration do you want? Once you are done with adding all of these nodes, you will be done with installing entire cluster. Okay, so similar is the architecture of Cloudera Manager, that you install Cloudera Manager on one of the machines, then start accessing it, and then start provisioning it. Internally, Ambari or Cloudera Manager is basically downloading Hadoop on all the machines and starting various services and configuring various services on all the machines. Okay, a question. Did it make sense to you, Pavan and others? This was really, really short overview of the installation. Okay, so I had been trying to install all the ways, as in I've tried Cloudera Manager, I've tried using manual way, but I found Ambari way to be really, really smooth. Okay, so you install Ambari server, then you install Ambari agents all around, and then install Hadoop through Ambari. Okay, a question from Gaurav, what's the difference between a name node and a management node? Which did I talk about management node? Did I talk about management node somewhere? You mean Cloudera manager node? I see you hear these terms in Azure implementation of Hadoop that we have at work and wasn't sure. I see. Probably management node probably would be this Ambari server node. Okay. Ambari server node is what they're referring, because in Azure, right? In Azure, the one they are using is essentially Hortonworks, and they call it HD Insights. That's the name you must be hearing. And in the HD Insights, it's basically the same Hortonworks Ambari package. Can we do hands-on on Hadoop installation? All right, that's something we have not decided as part of this. That's going to be a little bit wild, but you can definitely try. If you get stuck, just let me know. Okay. Okay, because this kind of setup would require us to take more machines. So I would say that one way of getting your own installation up and running is just download the virtual machine if you want of Hortonworks one and start it up. Okay, that will be quick. Okay, that's a quick way of installation. So this is how we had done even in when I talked to the people at InMobi, this is how they had done. Okay, and if you want to do it on your PC, then you can quickly just download the Hortonworks Hortonworks virtual machine. We call it HDP download. Okay, so you can try this. All right, so there is a sandbox provided to you. You can try that. Okay, great set of questions. Now moving on. All right, don't worry about the time. So here we go. Yes, that's what I'm coming to, Ricky. All right, great. So as we talked earlier, the data, the metadata, what is metadata? The name of the folder is a metadata. Okay. So a quick question to all. If I'm saying Hadoop fs mkdir, okay, xyz, it creates a folder. Okay, it creates a folder. Similarly, Similarly, when I go to Hue file here, I can say new directory, okay, and create the directory. Also keep in mind that this location is where it's going to create the directory. So I go back to
This
home.
one say use other.
Yes, somebody has unmuted himself. Okay, so is it possible for you to mute? Okay. All right. Now coming back to it, so you can create the directory using XYZ here, and it'll create that folder. Okay. So there are two ways to create directory, either from here or using Hadoop FS and KDIR. My question to you is, when I do this, we will be talking to who? We'll be talking to who? One, name node. Two, data nodes. Three, both. Yes? That's right, Nitin, Anil, and Ricky. You will only be talking to name node. Why? Because directory is a metadata. Okay? The actual data that starts from 0th byte, if this is the file, if you think about data, if this is the file, the data from here till here is the data. Rest, like file name and everything, is just metadata. So when we say make directory, it's essentially metadata. It's not real data. Therefore, when you say Hadoop FSMK dir, it will talk to only name node. So the answer is 1. All right. Is it clear to everyone? So if I say Hadoop FS copy from local, will it talk to name node, data node, or both? That's right. It will talk to both. Okay. Great set of answers. Moving ahead. Does that answer to your question, SP? All right. So name node keeps the metadata. Metadata is how many replica sets, what are the block IDs, where are the block IDs for the files stored. That's the metadata, the information about data. Okay. And the actual data is everything inside the boundaries of the file. When you say cat file, whatever gets printed is the data. So name node keeps metadata in the memory. And on demand, in older versions of name node, on demand, we could create the namespace image. Okay. And the namespace image is kept in the local storage. Periodically, as a part of schedule, we would create the namespace image and keep the namespace image in a folder. And from time to time, on every change, an edit log will be created. From time to time, the edit log will be created. Okay, so whenever from time to time we'll create the namespace image. I'm sorry. From time to time we'll create the namespace image. Okay, on demand, and as and when the user is making changes, whatever changes are being done in the name node, in memory, whatever the changes are being done in the memory are being persisted as edit log. As more and more more and more changes come in, more and more edit logs are being generated. Just like in accounting, before finalization of the accounts, every day accountants generally maintain a rough note of all the transactions. Okay, and periodically they finalize. Why? So that there is not much time taken in keeping the changes in the disk. Imagine that we are persisting the namespace image on every change. What would happen is, as and when you are making a slight modification to the metadata, the whole metadata will be overwritten in the disk again and again. On every folder creation, on every replica set change, on every updation of information, the entire namespace image would be stored onto the disk. That would have been extremely inefficient. That's why name on every change, there is added log created, and we can finalize that from time to time. Okay, so to since name node is a single point of failure, it's important to keep the data in the disk. In case it fails, at least we have something in the disk, because if something shuts down, everything in the memory gets cleared. All right, and then namespace image plus the edit logs can be combined together in case of failures, and we can recover the metadata. So given an older copy of namespace image, we can impose various edit logs in sequence and generate the metadata back. So what the first way of taking care of the failover was to maintain the copy of metadata. Metadata is image plus edit logs. Both of these set of data would be kept in a network file system along with the local storage. That was the first strategy to take care of. Now, the second strategy was to create something called secondary name node. Secondary name node was nothing but, again, similar to the name node, just that the metadata would have to be provided to the secondary name node before coming up. We'll have to brought up the secondary name node. It was essentially very similar to this setup. Okay. Now, third was this highly available system. This is something that happened in Hadoop 2.x. Okay. So there, the architecture of Hadoop file system was changed to accommodate high availability. And how was that done? There could be multiple name nodes. There could be multiple name nodes, but there would be only one name node. That would be that would be the main name node. Okay. So, and every data node will keep on sending the changes to both name node as well as standby. Okay. So there will be multiple name nodes. Only one name node will be in the main work, while rest will be standby. And all the changes that are happening on the main name node will be informed to the standbys. Okay, at any point of time, if name node goes down, standby would quickly take its place and become the name node. If the older name node comes back, the older name node comes back, that name node will stay as standby now. Okay, so it's like there is a single chair, and right now name node is sitting on this, and as soon as name node got down from chair, standby took the place, and everybody started informing him, and standby also kept on informing the older name node now. Okay, so all the name nodes are informed by the data node as well as the current name node. Okay, so standby is nothing but name node, just that it's not in that driver seat. Okay, and how is the driver seat managed? Using Zookeeper. Okay, so when name node is running, it creates a session to the Zookeeper with ephemeral node, and as soon as name node goes down, that ephemeral node disappears, and another standby creates its ephemeral node, and then that becomes the main machine. Okay, so we'll continue from here in the next session. All right, we will talk about we'll talk about it in the next session. A question from SP, the last question. So will that not cause latency issues? I mean, reporting to different resources, there will be slight latency, but it has been very well avoided by using the parallel means. Okay. So yes, let's continue the discussion from here. Wonderful set of questions. Keep the questions coming. And yes, this is the only way to learn. So yes, you can take the CCA 175 easily based on this content. All right. There's nothing extra would be required, but I would suggest that you can take a look at some of the question papers and so on. The directory will be, which directory are we talking, Partha? When we say mkdir, it'll be created in your home directory. Your home directory will be /user/Partha, your login name. Okay. In the HDFS, it'll be created in your home directory. Everybody is provided a home directory. As you open Hue, you land in your home directory. Okay. If you go to file browser of Hue, you land in your home directory. That's where the subfolder will be created. All right. Did it make sense to you? A question from Ricky. On an average, if you have 2 GB metadata in memory, how much data in HDFS does it represent? It's a very, very hard question to ask. Actually, I'll tell you something very interesting part. Can you give me an example when there is no file and still the metadata is 2 GB? Can somebody give me an example? There's no file in the system and still the metadata goes to 2 GB. Yes, you are right. You are right, Nitin and Ricky. Yes, so it's pretty impossible to do the calculation. So per block of each file, the metadata is around around 200 kilobyte, around not 200 kilobyte, around 1 kilobyte, not too much. I think 1 kilobyte is the right one. So um, each block generally takes a metadata of not around 100 bytes, not even kilobytes. I'll have to take a look at it. Okay, that's a better way of probably estimating metadata. Just see if there is how much space does how much metadata is consumed by each file. It would be somewhere around 100 to 200 bytes. Okay. How many standbys are kept for one name node? Generally 1 plus 1, that's it. 1 plus 1 is sufficient in most of the cases. All right, I look forward to your questions over the week, and please finish the assessments that we have done here. In case of Zookeeper, just finish all these 47, plus also finish the HDFS and other parts. Okay, there's quite a few assignments to you. I would strongly recommend that if you have not refreshed Linux for some time, please refresh it. Finish that part also. It won't take too much time. And trust me, data scientists or data engineers, half of their life is spent in struggling with the Linux commands. Okay, so I mean that's the truth. And even though no matter how much time I show you Hue, but truth is you are not going to use Hue in production environment. Okay, you're going to mostly spend time with the Linux console. Okay, a question from Pawan is, what's the equivalent other technology of Zookeeper? Honestly, I haven't encountered yet. The only equivalent is that people generally implement their own similar systems, but that generally ends up being useless. Yes. Yesterday's recording I had uploaded within 1 hour of the class, and you can go to my courses here when you take the cursor inside here. Okay. So there you can go here, and this is where you will find all the recordings. All right. A question from Rakesh. So we will have to finish topic 7. Yes. Okay. So with respect to the HDFS, we are still left with some of the topics. So this is where we are. So half of it you can finish. The fifth one is optional, absolutely optional. It's not really required much. Okay. The Java Essential is up to you. Actually, there is nothing much there. There are only Java videos if you want to watch. That's my previous recording of Java class. Next week, we will be covering Yarn and HDFS plus MapReduce basics. Okay. We will increase our focus towards Spark. Okay. And not yet, Sanjay, but we will provide you something. Let me take a look at what we have. All right. I look forward to see you next week, and feel free to keep asking questions. All right. Bye-bye. Have a good day. All right. Don't worry about the space. We are going at very good pace. Just make sure to get your doubts cleared. Do not keep any questions to yourself. Okay. You're not disturbing the class by asking question. That's you are actually helping others because they might have the same questions. And since everybody can see the question, therefore it's easier to learn from each other. Okay. So great. All right. See you next week. Bye bye. Have a great week ahead.